Hey, welcome back to our videotape series. The AutoCAD class has a number of different drawings then that we started this semester, and we're getting into connecting with loops and arcs, and this week we're introducing the topic of an ellipse. I have two drawings that are a part of ellipse, and then I have two other drawings then that are very much arc driven. We'll look at creating an arc. We'll do an offset from that arc. We'll also use the tangent radius command to put another part together. So I have four of them all together here that we'll try to get in here in the next couple of hours. So let's go ahead and get started. Whenever I start a drawing, I always like to start a drawing that is mostly an X, especially if they're mostly circular. And we want to get them so that they're certainly at right angles. I can actually do that by making these two perpendicular. And there you have it. By using our parametrics perpendicular setting. So the first two pieces that I want, we'll start with some circles. I'm going to start with two diameters right here in this corner, and 1.75 is the first diameter, and the second diameter is 2.25. Now we've made something similar to this. It's like the gas cap on your car that has anywhere from 4 to 6 prongs that you inserted and then give it a half a turn or quarter turn and it locks in. So we're going to do these, and these tabs are set off at a 30-degree angle. So as we start doing a line, notice that AutoCAD allows you then to either give you a line in either distance or angle. When I hit the tab key, I can switch back and forth between the two. And we want this first line to be, we don't care about the length, but we do care about that it is 15 degrees. Let's go in the other direction. This would be the same thing. Remember that AutoCAD always takes this line that moves to the right as 0 and then counts it out in terms of degrees. When it gets to this one, it gets to 180. And now on the opposite side, then it counts down. Let's hit that tab key and do 15 degrees. One of the nice things about AutoCAD then is, since you've already established a straight line, it will try to do it in the opposite direction for you, which makes life a little easier. And since two straight lines, then if this is 30 degrees, then the opposite angle will also be 30. Here we want one going across the vertical tail, and you'll notice though that this is 90. So if I take that and minus 15, I bet you I'll get 75 degrees. So let's hit the tab key, put that 75 degree in. Now let's just check, and I bet you we can get 15. There it is. So there's our 15. Let's do it on the bottom side. Hit the tab key, 15. Oops, not 15. I'm sorry. 75. Again, we've established a straight line, so we'll take and allow AutoCAD to draw the next one for us, and then the next one. Sweet. So there we go. Now these outer fins will be on the outside of the drawing. So these will be a hole that will be placed on the outside of the drawing, and then this inner part then. So let's do our trim command, which is the scissors. Let's touch all the components that are available for that. I'll hit the space bar then to arm the command, and then we'll start taking away. So I want to do inside, outside, inside, outside, inside, outside, inside, and then outside. Now let's take and trim those out. Here. I'm going to take 2 clicks because I got 2 lines in there. And there you have it. So now there's an outer ring that goes around that, so let's put that diameter in. And that diameter is radius. Radius. There it is. Radius 1.75. Now there's 2 other circles that are out here that are connected with this oval. So let's draw that line out here. And then the first one is 2 1/4 away from that point right there. Let's do our offset then. Grab the horseshoe, 2.25. Put that one there. And the next one is 9.25, but it doesn't go back to the center. It's in addition to this one. So we have the 2 centers out here. Each of those gets 2 circles, 1 radius and 1 diameter. Radius 0.75. Diameter 0.75. And on the other end, diameter 0.5 and radius 0.5. Okay. I'm going to stretch that line just a little bit out on that direction. Okay, so the ellipse is, the quarter ellipse is going to be on this top half right here. So I'm going to grab the first one, which is using the center. Here's our center of our ellipse. The flat edge is going to go out to our almost 12 inches. And the top part of it ends right there. When we use our trim command, now the last drawing I did wouldn't allow us to use it on the circle like that. This time it did. So there's our first radius, a quarter arc of the ellipse. Now let's do the second one. So I actually have to find the center of this. I can try to find the midpoint, but I still have these lines hanging out. What I could do though is just take a line and draw it and use the end of the line, 4.75 then, as the center point between it, and start from there. Grab the ellipse, and it actually goes from here, not all the way up to here. It only goes 1.5 of the way up there. So let's type 1.5 and then put it in there, because the major radius from here to here should be 8. Let's take a look at this major radius. So there's our major radius of 8, and then the minor diameter, which would be from here to here, should be 3, and I believe it is. Okay. So that's what the book tells us to do. Sweet. So let's trim that off. The space bar and take that out. We have one more thing in between. Here is a fillet. use the fillet command. You have to go to the bottom fillet, and we need to type in our radius. So our radius is going to be 1.5. And that didn't get it. Why? Fillet. Where's my line for radius? I'm going to hit R for radius, see if it'll pop up. There you go. So that will be 1.5. Touch this line and this line, and there we have it. So the part's done. We're going to do a little trimming. Let's take those guys out. Space bar, space bar. There we go. Okay, let's delete our construction lines. And there it is. Oops, this one's not here. Let's take that one out. There we go. Now we finished it. All right, so one of the things that, in terms of our notation, is to call out the ellipses, and this ellipse then is going to be called out by using a leader, and we want to touch somewhere on this circle in order to get that to happen. I can't find it a spot, so what I'll do is I'll just quick draw a construction line right here, and then notice that my leader arrow locks right down into that. Give another click, and now I'm ready to start typing. So this is a quarter ellipse. And it is 24 by 6. Do I want to be done? Yes. Now these two numbers are called out as major and minor diameters. The major diameter is the one going horizontally, so that is the longest of it. And then the minor diameter would be the upper distance going in this direction. So as we look at it then, this is only 1/4 of it, so the rest of it then would be over here, and then the rest would be, you know, come around up along the other side. Same way with this one. I'm going to add just an extension line here, just a quick one. We'll call this out then. This is a semi-ellipse. And its major is 8 inches by 3. Do I want to be done? Yes. And then let's just get rid of this, because it wouldn't attach itself to anything, so we just forced it at an intersection. All right, so the rest of this is pretty minor. Let's go ahead and put center marks. Put those like that. That allows me then to something to dimension. We can do the quarter. There we go. And you'll notice since this is taken out to the 4th decimal place, it really does go quite accurate out there. 2.2500 we could do. Do I want to be done? Yes. So that gives us a little better view of it. Let's do the 9 1/4, which we were able to get from here. There, I got it. Okay. So that dimension, build that one. Oh, like that. Okay, so let's see what we got here. So we need an angle dimension. What else? That looks like about it. We'd want to put a title block on it. We'd want to put our name. Remember now the name goes in all this texting. We could put the hour that we're here today, and then we can go ahead and print it. Now, let's see what the print style is going to look like. So under the big red A is print. We'll go find my printer. In this case, it's the 8150. I'm in my classroom today. We want to put a window around the drawing so that we have just this that it'll print. And then instead of hitting OK to send it off, let's just first look at, see how this would go. So you can see we have a lot of white space here at the top. This drawing is not real proportional to 8.5 by 11. So what I would do then is I'm going to stretch this up. Maybe go more like that. I want to try to get the part in the center. Let's see what that looks like. So print, window, preview. All right, so we got rid of a considerable amount of white space up here. Looking like a pretty nice looking drawing. Unfortunately, I don't know the name of this one. I cut it off, so we'll just call this a no-namer. Something like that. Okay, so let's move over and grab some more clear drawing space. Let's start this one over here. Now this is a elliptical cam. Cams are a way of creating rotating movement and turning it into linear. As the cam turns, there would be what they call a follower, which would be on the cam edge and going straight up and down as the cam would move. The cam is eccentric type of moving, so that there's all kinds of movement related to the center. And as an elliptical cam, the movement is pretty straightforward in that the cam will go up, our lifter will go up, and then as the cam rotates in the lower position, then our lifter will rotate down. So let's go ahead and give that a try. So we want to start with then, again, because we're mostly circular, we'll start off with a circle and a center. And we'll use this center as the center of our ellipse. So the ellipse then is, our 8th is going to be the major and 5 is going to be the minor. So let's draw out half of that. So we'll do 4 by 2.5. And that should do it. Let's just check to make sure. So there's our 8. And this will be our 5. Yep, so that we got it. Okay. Now the drive shaft for the cam is located on this side, and that is 2¼ inches away from the center. Easiest then to do then is, let's do our offset, 2.25, and that'll establish ourselves a new center. The shaft hole is set up to be 1 1/4 inches, so 1.25. And then the outer collar to that is set up at 2.5. So this is where our drive shaft will go through. This will be the hole, and we'll eventually come back and put a keyway on here to lock the two together. Now, we don't need this as a solid cam, so we're going to open up a spot here on the inside to save weight and save material and reduce the weight of it, in which shipping costs, less steel is a good idea, so we can open it up. So let's start opening it up by putting a ridge all the way around the line, and that ridge is set at 5/8. So again, just to show you something here, I can actually type in a fraction. I can do 5/8 as long as it's just a fraction. If it's a mixed whole number, AutoCAD doesn't like that. So I can do the single fractions like this, or I can put in the decimal equivalent, which would be 0.625. We can do it either way. Remember that offset is a two-step type of command, in that it allows us then to pick the command. We actually have to pick our offset, and then we can create that offset, and it copies it exactly at the distance that we want. So this is the outer edge of the hole, and now we're going to come back in, and now we have a center post coming down the center, and that is also 5/8, but we want to do half of that on either side, to get a total distance of 5/8. So half of 5/8 is 5/16. All you have to do is double the bottom number. 5/16 then would be the half. Hit the space bar. And that would be that centerpiece that we would need. So we'll have the ring, the centerpiece, and now these are open spaces. Now, anytime that you have sharp corners on a part, like here and here, those are always our weakest positions. So we like to put fillets in there, and as we put this fillet in there, it creates a much stronger part, because anytime there's a corner, here's where it really likes to go. So it's telling us that we have fillets then of 0.5. So now, I don't know why, you typically have the command bar will pop up and give you that information, but I don't know why it's not doing it. But I can hit R for radius, and now it'll ask me for that radius. And we want it 0.5. And now we'll go ahead in and fill those radiuses. I'm going to arm it again with the space bar. And one more on this side. Again, let's repeat. Okay. So let's use our trim command now to take it down to the original part. And we'll eliminate this arc. Oh, look at that. Again, we're having issues with these arcs. So let me try just touching them individually. And it won't go on us. Okay, I know how to, well, let's find the intersection point. Let's just put a line here. Now you shouldn't have to do this. This should have taken the tangent point and trimmed it for us. And it's not liking that either. Well, let's touch everything. Well, let's try over here on the other side of the drawing. So we can remove that and that. Oh, see, there it went. See, I had issues with that earlier today, and that must be why we're having problems with it. Okay. Well, let's try something here. So I have a mirror command that I can take this line and I can mirror it exactly up, because I have a nice center line, and since this is symmetrical, the mirror command will allow me then to take this line and see, it doesn't seem to be connected there. Let's do this. I'm going to use my tangent and force these two together, and I'm going to force these. Oop. Okay. I'll force those two together. Now, can I force those two together? Yep. Now then, mirror command. Well, let's try this. There we go, now it works. Okay, so let's do the mirror. Take this edge, and now we want to hit the point to mirror it. There we go. Oops. Then hit the enter button. Okay. So you see they're a little off. So let's go ahead and then take our parametrics and make sure that those two pieces are tangent. Well, this is the darndest thing I've ever seen. I did it that way then. Okay. So there's our part. That was a struggle. All right, so let's go ahead then and drop the keyway in here. Now the way this works then is we're going to cut out a little section right here. And then we're going to insert a shaft. We'll have the opposite type cut into it so that we can drop a piece of metal in here. And then have our part. So the keyway then is set at 3/8 by 3/16. Now it's always the width that goes in this direction, which is the 3/8. And then the 3/16 then will come out in this direction. So let's first of all do an offset and a 3/16 on either side. Give us our width. Now I'll start here and start a line. Go in the same direction, 3/16. Whoop. Come across and attach it here. And now all I have to do is trim. I hope. And it did it. Okay. So there's your slot. And as I said, as the shaft would go in here, it would have an additional piece right here. Let me just draw something in here real quick. So if we had a shaft that would go in here, we would have the same kind of line that we would have an opening right here. In that piece, so there would be that opening, and then that additional part then called a keyway would be added right in here, and that would lock the two together. Yeah, that's not what I wanted to do. I didn't really want it to snap to the corner. So that would be this piece right here. And that would be an additional part, and now that locks the two pieces together. So as this cam would rotate, then, like this, our piece then would ride up and down and would go vertically up and down as it would ride as it would write on this top section. So let's delete. I'm just hitting the delete key. And let's take this guy out because he's really not part of the initial drawing. Okay. So a couple things in order to call out the ellipse. Again, my leader command for some reason just won't attach to any one of the parts, so I'm just going to use kind of an intersection piece here. And we'll type this in. And this is a 8 is the major diameter by 5 ellipse. Are we done? Yes. And then down here, we'll call this out then as a 0.375 by 0.187 keyway. We done? Yep. Take our construction line out. All right, and then this is pretty much similar the way we would set dimensions, call out our radiuses. Got that one. No, here we go. Should tell them how wide this is. What? There you have it. Title block, my name, okay, let's take a look and see how that one would print. So print 8150, window. Let's preview it. All right, not too bad. A little white space up here. We could have moved that bottom line up some. Give us a better looking drawing. Pull some of that white space around. Okay. The only other thing that I've had classes do in the past is actually put the hour up here and the name of the class, Introduction to Computer-Aided Design, and then I would have them put the hour. It just makes for a little nicer product when you're all done. Okay, so that's 2 drawings. We got a little more time here. So let's take a look at the next one. This one then will have almost the same thing, but we've got an open space in the center to contend with that we'll have to deal with. Again, always start with our big X on the screen. This thing is mostly circular. I'll make sure then that we're at right angles. There you have it. And we'll start. This end right here has most of the circles. One is diameter, one is radius. The diameter is 1.5, 1.5. And then the radius is 1.25. Now we have to establish another center out here just like we did before. And that one is just below this center. It's a 1/2 inch below that. So let's just go ahead and do that one first, 0.5. And then it's 4 3/4 from this one. So 4 3/4, 4.75. So we'll establish that circle, and that happens to be a 1 inch diameter. So there you have it. Now, what I did is created some lines off of here. We just stretched them out. Because we have an arc that's going to be tangent between this line and this circle. And we can use the TTR command to establish that. So let's use that TTR command. So it's tangent to this line and this radius, and it is 1.5 is the radius of that arc. So you can see we didn't stretch this out far enough. That's okay, because we certainly can pull it out to there. And now let's trim, maybe. Let's try it. Okay, like that. So that's our first one. Now, they're telling us then that we want oh boy, I did this wrong. That's not the one, that's not the intersection that I want. It's off of this one, because we want that arc. So let's try it again. Well, let's get more practice then. So here, and our arc was 1.5. So that was our TTR. That looks better. I knew that looked kind of weird. Okay, so there's that one. And now we need an offset that will be, all of this needs to be at the same thickness. So what do we have here as far as a distance? So it's a 1/2 inch. So let's do our offset of 0.5. You do something like that. From here to here. And you can see then that we'll trim this out. So that's how that's connected out there. And then we have some other pieces that we'll walk around here. I'm actually going to take this one out and actually put in a real dimension. So the book calls this 2 inches. Then we're going to go up 0.5. Going to come back in this direction of 0.75 and then intersect right there. So we need an I and T to intersect. Whoop, I and T, and that'll give us a nice intersection line. Well, I'll do this. And then trim. Okay. We don't need this circle, at least on this half. Trim that out. Let's get rid of our construction lines. All right, and the last thing, remember what I said about square corners on machine parts. Anytime that there's a square corner, there has a tendency to be a breakage at that point. So we'll certainly want to put a fillet in there. I'll hit R for radius. And they want those radiuses at 0.25, and they want it in this corner, space bar, and in this corner. And there's our shape. Under annotate, we'll get the center marks. We'll want one here and here. And now we can start to dimension. Notice then they're called out. One is a radius, one is a diameter. We'll get this 2 inches in here. Huh. That's supposed to be 2 inches, so let's just fix that. The dimension from here to here was 1/2, and we needed 3/4. Now, I don't like the way it's laying on that side, so I'm going to grab this. Oh, that's way too much grabbing. Pull this dot and pull it over here. Call out my radius, my fillets, one there. But sometimes you have to zoom in when there's small arcs like this to zoom in to find those pieces. Let's get this radius now. Notice that instead of the diameter, it changed out to a radius because we opened it up. And there you have it. Title block again. This is a simple one, huh? And we didn't get a name for this one either. Text. 2 clicks. Two more enters, and there we have it. Let's just raise this one up a little bit. Okay, so now what do we look at? Print. Printer. My room is the 8150. Window. We do window because we really don't want it to print all the screen. We only need this distance around the part. And then let's look at that. Pretty nice. Again, a little bit less We could use a little bit white space up here just by dragging this line up, dragging it in both directions, making sure that our part is in the center of the drawing. And that would look pretty nice come the end of the day. All right, now I got this one is a tough one. This one took all my skills in terms of being able to teach this one and have students follow along as far as how this one is set together. I'm gonna take a little break right now. I'm gonna pause the tape and we'll come back here in a minute. So we'll just do a pause. Okay, and we're back. We're back live. The next one is a rather large drawing, and it has to deal with making slots in an arc fashion. Again, it starts off with what we've done in the past is created our lines, mostly circular. Let's just make sure using our parametrics that they're perpendicular. So there we have that. Now, we're going to start here at the bottom and we'll make a couple of circles. So we have both diameter, so diameter of 4 inches and diameter of 2 1/4, so 2 1/4. Okay. Next, Next, 8 3/4 inches away from that, 8.75. We have the same outer circle, so rather than redo that, I'll use a copy command and move that over. And then this is a smaller circle on the end, which is only a 1 inch diameter. Okay. Now the rest of this part is going to go up in this direction. So we have a large arc that we need to contend with that will be starting off. This is the main center here for most of our pieces here. So they're asking for a radius of 8.75. So let's do the radius of 8.75. 8.75. Okay. Now then, this is the center line for the slot that we have going in this direction. And the center line is at a 60-degree mark. So again, remember that as we looked at our hitting the tab key, we can switch back and forth before distance and angle. And this one we want 60. And the next one we want 100. And there it is. We want circles. We'll want 4 circles at this point. So they are 1 inch here, 1 inch here, this one is a radius, .75. Yeah, that can't be right. I think what I'm going to do is I'll make it the same as that one. So what I'm going to do is I'm going to copy that here. I don't like the way that other one looked. And go like that. So now let's connect them. Now, we haven't used the arc command a lot, but we have the arc command here, which we then can do center, start, and end with that. So we can start with the center. We'll put start, and we'll put end, and it makes a very nice connection. Center, start, and end. Center, start, and end. And the last one, center, start, and end. Okay. We'll trim. And there's that piece. Now, let's connect all these pieces together. We have this radius goes here now, center, start, and end. So that's the outer edge. Let's take this one out so we don't get confused. We have a straight line at the bottom. And then this has a TTR, and that radius for circle is 2 5/8. So we've used a number of commands. So that TTR, so click here, and then we enter the radius of 2.625. Lays it in there like that. And now let's trim all of those pieces out. Really, it's only this that goes away. Hit the escape key, and now we'll erase our construction lines. And there you have the completed part. Center marks, under annotate. Like that. Now I'm going to put in some lines in here as being part of our dimension, and it really won't look too different than our dimension line. That we can call this out. So it just looks part of our extension lines. So let's go ahead and get this. So I'll take this one and this one, and that will be our 60-degree mark. We'll connect this one down to here, and this will be our 100. And then we'll go back to the traditional dimensions. Call that out. This one. I think that's it. The hardest part of the whole drawing, once you establish your angle lines, putting that first radius in that we established, which was our 8.75 line in here, and that established the center for this part. And actually it's the same thing as we have here. So these two circles are in line, as well as these outer circles are in line. And it worked out pretty nice. Let me move this in just a tad. Okay. So now this isn't going to fit. Notice how big that drawing is in comparison to these other ones. This is not going to fit on our normal title block. So, but the paper, the AutoCAD will shrink it down to an 8.5 by 11 piece of paper that will be proportional. So we'll see how this comes out. Although remember then, as the drawing expands, you know, you may want to increase the size of your lettering just a bit on your dimensions to give it a little better feel, because as the part gets larger with our dimensions staying the same size, they could get lost in the shuffle. So let's, for shits and giggles, let's see if we can find dim style, and let's go ahead and see if we can't modify our dimensions. So our text height is 0.18. What if we were to change that to 1/4 inch, 0.25, and then pick OK. Pick OK. Okay, so did you see the numbers increase in size? The dim style command is where you'll find all of the changes that you might want to use, anywhere from arrow size to how much gap is here at the end, this little guy right here, how high you want the letters, the text height. So now let's put a name on the drawing, and I'll change this to 0.3 3. Make this a little bit bigger. Now let's see what it looks like. So let's go print. 8150. Put a window. Again, this will shrink that drawing down to an 8.5 by 11. So see how well it fits on the page. So we have white space on this side. So I would take this line and just move it over just a little bit. We got a couple of minutes here, let's do that. So let's just slide him over. Try to keep our part in the middle. Now let's take a look. Print. Window. Preview. Oh baby. The other looks really nice. Man, give the amazing Mr. K, give him an A. A+. All right. Well, that's what it looks like. And we've got the 4 drawings completed that we've done here in the last week. Now we have the videotape of it so that if you need to go look at it and review, you have it. We'll have it on our website here at the high school for the CTE department, and then we'll also store it in your Google Classroom. So, hey, thanks for coming today. Let's go ahead and shut her down, and we'll see you next time.